Number one tells us that a certain psychologist is counseling people that are getting divorced, and what this psychologist looked at was how many relationships that person had before marriage and then the length of their marriage. So did someone, for instance, the first one here says that this person, the three, we would interpret that as that person had three long-term relationships before they got married, and that their marriage lasted 9 years. If we talk about, you might wonder, well, it's 0.5 of a relationship. They don't really tell us in the problem, but if we were to speculate, we could assume maybe that was maybe that was one person that they dated, but it was not too serious of a relationship, right? So that's maybe kind of how that we could think of the decimals. So the first thing we want to do is to get a picture of what's happening here. So we want to construct our scatter plot. So let's grab our calculator here. And what we're going to do before we do really anything with the calculator, we want to reset it to make sure that nothing's funky going on with the calculator. So where I went is I did second, and then memory, which is the plus sign, and then 7, 1, and then 2. And then so it says that we've reset our calculator. Where we want to put in our numbers is we're going to go stat edit, and then this is our x value is going to be our L1. So here's our L1, and then our y value is going to be our L2. So let's put in our x value. So we've got 3, and we've got 0.5, and we've got 2, and we've got 1.5, and then we've got 5. And then length of marriage, so it looks like we've got 9, 6, 14, 10. Nope, not 1,000. If that happens, if you end up making a mistake, you can type over it. So we can just, for instance, we can type 10, and then we've got 20. Okay. So what we want to do is that we first of all want to see a scatter plot of this. So what we'll do is that we'll go to second stat plot, and this is where we graph our statistical graphs. So we want to turn on that setting. So we'll do plot 1 and we'll do on. And then the first graph that's already highlighted for us is the scatter plot. So that's something that we could don't have to change. We'll just go ahead and keep it as it is. What we want to do is tell the calculator that we're graphing a statistical graph versus just a regular line. So what we'll want to do is we'll go to zoom, and then we'll go to zoom 9 or zoom stat. And then we end up getting a scatter plot that looks something like that. If I wanted to see the actual numbers, I can hit trace, and then that will show me, for instance, that particular point is 3, 9. So we see that this pattern looks like that it's going uphill. So we would just want to sketch it ourselves real quick. So I did it first in the calculator, 1, because we're going to need that information for the other problems, but 2, I just wanted to have an idea of what it looks like, so that way when I do it myself, hopefully I don't make any mistakes. So again, x represents number of relationships. So we could say number of relationships, and then our y value, relationships, and then our y value is going to represent the length of marriage. So we'll say length of marriage, and this is going to be in terms of years, right? So this will be in years, will be our units. So as far as on the x, we just have to be able to count up to 5. So let's just count up to 5. So we'll say 1, 2, 3, 4, and then 5. 1, 2, 3, 4, 5. And on the y value, we have to be able to count up to 20. So maybe we count by 1s here, but we also could count by 2s if we wanted to kind of simplify things a little bit. So let's say 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Now you certainly could have counted by 1s. It just would have ended up being maybe a little bit more on your paper, but we would have got exactly the same thing. Alright, so let's plot the points. So we've got 3, 9. So here's one of our points. And we're just sketching this, by the way. So in terms of accuracy, I mean, we definitely want to do the best we can with it, but at the same time we realize that we're just doing this by hand. But when we're done, what we want to see is that we want to see that what we did by hand should look roughly the same as what our calculator came up with. So there's my scatter plot. Let me compare that to what the calculator did. And we could see that there's a fairly good connection between the two. So there's my picture of what's happening. So what it looks like is that the numbers are going up. So what it seems to be is that the more relationships you have before you got married, the longer your marriage will last, or at least that's what this is. And we should mention too is that this is a very small sample. Asking 5 people a question, it does not make for a good study, so we have to kind of keep that in mind. You'll see something here that says interpret the correlation coefficient. So what we want to be able to do is actually come up with an equation that models this situation. So what I'm going to do is that I'm going to run my linear regression. Now before I can do that, I have to make sure that there's some settings that are turned on. So what I'm going to do is I'm going to go to second and then catalog, and I want to scroll till I get to the D section of the alphabet for diagnostic. So I could just scroll, or I can also use the alpha key to jump to the D, right, which is where it says matrix there. And we did not jump. Let's try that again. There we go. We jumped. Or you could just hit the down arrow all day long if you want to do that too. So we want to turn on the diagnostic. Basically what this is just that when we do our regression, and just hit enter, when we do our regression, we just want it to give us a couple other pieces of information. So I've already got my numbers listed in stat edit. So now what I want to do is I want to go stat calc, and then the type of regression that I'm running is number 4. It's a linear regression. Our calculators may look a little bit different at this point, but you should say linreg, and then you're just going to hit enter, and I'll hit calculate. Right? And then so we should get something that matches here together. So what we could say here is that y equals, and we're just going to want to write down the equation that it gives us. We can round that. Let's just round to maybe 1 decimal place. So let's say 2.7. So 2.7x plus, and then the second part of that would be 5.4. So we'll say 5.4. Right? And then there's a couple other numbers that it gives us. It gives us the correlation coefficient, which is the where it says r. So we can round that, let's say, to 0.85. So we can say that the r is equal to 0.85. And then the coefficient of determination, which is what the r squared gives us, is going to be 0.72. Okay. So interpret the correlation coefficient. So r equals 0.85. What does that mean? Who cares? Well, what this is a measure of how strong or weak there is a connection between two things. So we're wanting to know, is there a strong connection between how many people you date and how long your marriage will last, or is there a weak connection? What we find is that the closer the number is to 1, that means that the stronger that it's going to be. Now, what's the difference between 1 and -1? Well, the difference is that is it a positive correlation? Is it something where as x increases, the y increases? Or is it a negative correlation? As x increases, the y decreases? Well, in this case, what we find is that, or at least what this graph is suggesting, is that the more relationships someone has before marriage, the longer the marriage. So how we can interpret this is that a positive correlation means kind of the more the blank, the more the other blank. And when I say blank, I mean x and y. So the more people you date, the longer your marriage is going to be. Something that might be a negative correlation, and we don't see that here, but that would be the more the x, the less the y. Right? So an example of something that's a negative correlation might be, the more you miss school, the lower your grades are going to be, right? So as x increases, y decreases. In this case, we're saying as x increases, more relationships, that the marriage tends to last longer. Now, in terms of what does this number represent, that 0.85, so it's positive, and it's close to 1, so we could say that it's a strong positive correlation. So this number suggests a strong positive correlation. And what we mean by that is that exactly what we just said in the next sentence here, correlation. The more relationships someone has before marriage, the longer the marriage. Part C says interpret the coefficient of determination. What this does is that different than R, right? So our R value tells us whether it's strong or weak. It's a strong connection, a weak connection, and is it increasing or decreasing? What the R squared gives us is a measure kind of accuracy, confidence in our model making the prediction. So an R squared of 0.72, again, similar to R, closer to the 1 the better, or the stronger. So what this says is 0.72 is that it means that 72%, right, because if we converted that to a percent, 72% of the variability, and when we mean variability, we mean that, because you notice that the those points don't fall on a perfectly straight line, right? So 72% of the variability can be explained by our model. And what we mean by our model, not Tyra Banks kind of model, but this right here, right? So a mathematical model we refer to, we made some observations and then we want to be able to make predictions, right? Part D says interpret the slope in context, right? So here's your slope in our equation. So there's our slope. And what the slope refers to is really kind of the rate of change. So how is something changing in the problem? Another way that we can kind of think of it is that it's the change in y over the change in x. That triangle right there, by the way, that means change. So that's a notation you see in math. You also see it in physics. It just refers to a change in something. Well, what's changing? Well, the y is changing, which is the marriage, over the x, which is number of relationships. So what we can say here is that as the number of relationships, right? So for every relationship before marriage, a person's, or at least this is predicted, before marriage, a person's, right, so a person's marriage length of marriage will increase by approximately 2.7. So we can kind of scroll here a little bit. The person's marriage will increase by 2.7 years. So what we can tell is that this pattern, this is going up. How much is it going up by? Well, our model suggests that for every relationship you have, your marriage is going to last 2 more years. If another relationship, another 2 years, right? So that represents our slope. So now the last part of this, I'm just going to scroll down here a little bit, and you can pause or rewind if you needed to get some of that information from the top. But so part E here says we're going to construct a residual plot. And so what we want to do with the residual plot is that we want to compare actual and predicted, right? So what we mean by that is that we gave a survey to these 5 people and asked them, hey, how many people did you date? How long did your marriage last? And then we created this model that made a prediction. So we want to compare how does our model hold up to with what actually happened. So what we're going to do is that within the calculator, we're going to have the calculator help us with that, is that we have our regression, And what we're going to do is that I didn't save that equation, so you see there's no equation there. When I go to graph, I just have my scatter plot. So what I want to do is I want to rerun it to where it actually saves my equation. So I'm going back StatCalc 4 again. The difference here is that, and again ours is going to look a little different here, what you should have is linreg. Don't hit enter yet, and I want you to do vars, yvars, enter, enter, and you'll see where it says y1. Again, ours is going to look a little different, but yours should say linreg y1. Now hit enter. It'll do the same thing, right? So it's the same thing we got. Only difference now is what we told the calculator to do is take that equation and save it into y equals. So what happens is that equation, I didn't have to retype all that. That equation is now there. So when I go to the graph, I can see that my line of best fit is drawn into the calculator there. So you notice that it doesn't go through every single one of the points. And so what we do with the residual plot is we compare how far off were we. So this one, the line and the point are pretty close together. So that was pretty close, right? But you notice this one, we are a little off on this one because there's a distance from our prediction, which is the line, and the point, which is what actually happened. So what we're going to have the calculator do is we could do this math by hand, but we can have the calculator actually help us out with it. So what we're going to tell the calculator to do, let's go back stat edit, and I'm going to tell the calculator and I want to see the actual and predicted side by side. So here's the actual, what we typed in, and then I want to see the prediction, which is what we would have got from our model. So we're going to put in our equation, which our equation is stored in y1. So we're going vars, yvars, enter, and then so you notice right here it says L3 is equal to y1. What we want to do is we want to put all the numbers in that column. So we're telling the calculator, hey, take that equation I've got saved in y1 and plug in all of these x's, right? Because remember your L1 is your x's. And we could do that manually by hand, but that would take a long time, or take more time than what we've got. So we're going to type in L1. So now what we see there is that we see these are our actual, and then we see the predicted, and then what we want to do is find the difference. So we want to find, well, okay, how far off were we? So what we're going to do is that we're going to tell the calculator, hey, this L2 is what actually happened. L3 is what I thought would happen. Find the difference between those two things. So my actual is an L2. My predicted is an L3. So I'm saying L2 minus L3. Again, make sure you're in the heading of this column. You're not actually down here, but you're actually up there in the heading part. And then let's hit enter. Right? And then so what we want to see is that these are all the differences. Right? So our actual was, this person actually was married 9 years. We thought they'd be married 13 years. So our prediction, the actual was actually 4 less than what we predicted. This one was actually pretty close. Actually 6, we predicted 6.7, so not a very large residual there. And the reason why we're doing this, for a couple of reasons. One is that we want to see, again, the differences between actual and predicted. But we also want to answer this question right here that says, is a linear model appropriate? So what I'm going to do is I want to sketch my residual plot. I can certainly look at the numbers here, but it's really not easy on the eyes. A picture or a graph is always easier on the eyes. So what I want the calculator to do is actually do the stat plot for me. So I'm going to go back to second stat plot. And this time, instead of it doing a scatter plot, what I want it to do is I want it to do the residual plot. I want it to graph the differences, basically. Well, the differences are located in L4, right? Because that's where we put the residuals. And then let's redraw the graph. So from here, actually let's go back. So from here, I'm going to do zoom and then 9. And then I have my residual plot. So I'm going to have something that looks roughly like this. I've got my residual plot. I've got a point here. And let's see, I guess my thing's going to go away. I got a point here. And again, I'm just sketching this. I've got a point down here, and then I've got a point over here. If we were going to make this by hand, what this represents is that, again, this represents our x's. So this represents our, 1, and then we had one at 1.5 and we had one at 2. So we could say maybe 1, 2, 3, 4, 5. And then our what's on the y-axis is the actual residual. So for instance, if I wanted to know what this residual is right here, I can hit trace and I can scroll over to what that would be. So for instance, this point right here is that when x is equal to 3, that we were off by -4, right? So this would be, this would be a -4. And then so what we could do is then plot, and again, we could see the numbers, we could look at the graph. The reason why we're doing this is that what we want to do is we want to say, is a linear model appropriate? Well, again, I can go back and I can look at my scatter plot. It looked like it was linear. And again, linear meaning that it's roughly a straight line, right? That it's not curved. We also look at the r and r squared, which were both close to 1. And then we look at our residual plot. And what we're looking for here is that if you see a pattern, then what that means is that it's non-linear. But if it looks like the points on your residual plot are randomly dispersed, then we could say that that would suggest a linear relationship. So these points here, randomly dispersed, so what we can say then is that we would have a linear model. So what we would say is, kind of in our little bit of a write-up here, is just to say that because of the residual plot is randomly dispersed, that's going to suggest a linear relationship. So we can conclude a linear relationship. Okay. Last question here is about making a prediction. Is that if someone had dated 4 people, how long would their marriage last? Well, the person that dated 3, theirs lasted 9. Person dated 5, theirs lasted 20. So we just want to be able to make a prediction. So what we could do with that, a couple different things we could do. One, we could just take our equation that we got from the very beginning, our y equals 2.7x plus 5.4. And then we could just substitute in 5.4. We could just substitute in 4 for the x, and then we could see what that would give us. So let's say y equals 2.7 times 4 plus 5.4. And I could just throw all that in the calculator. So let's say 2.7 times 4 plus 5.4, and that gives me 16.2. So that we could say approximately 16.2 years. Now, that's okay, but to get a more accurate picture, what we could do is, let's go back actually to our table. We've got our equation in there. If you go over to second and then table, here's all of our predicted values. So if we wanted to scroll down to 4, we see 16.094. So there's a little bit of difference because we rounded there. Either way, though, we could say, roughly or approximately 16 years would be our estimation there. All right, so it was kind of a lot of information in one problem, but we just wanted to go through each one of those little pieces. So go ahead and stop the video now and try number 1 on the right side.